The first one says a candle has been burning at a constant rate of 1.25 inches per hour. The candle has been burning for 4 hours and is 5.5 inches tall. What's the length of the candle before it was lit? So one thing we might realize on this is that it says that the candle is burning at a constant rate of 1.25 inches per hour. So if we have a constant rate of change, that means we're dealing with a linear function here. So in other words, I can write the height of the function, or the height of the candle, as a linear function. So the height is going to be decreasing by 1.25 inches for each hour, plus some initial amount. So this is my rate of change of the height. T is the time in hours. It's just a linear function, and H is the height of the candle. And B here is my initial height. And so if I plug in the values that I'm given, that after 4 hours it's 5.5 inches tall, so I can plug that in. 5.5 equals negative 1.25 times 4 plus B. I can solve for my initial value. So 5.5 plus 1.25 times 4 gives me 10.5 inches, which makes sense. If the candle's burning, it's going to be getting shorter. So these answers don't make sense because those are too small. We want to choose an answer that's going to be bigger than 5.5 inches because it's going to start out bigger and it's going to be getting smaller as time goes on. So anyway, so the answer is 10.5 inches. On the next one, I have the height of water as a function of volume of water. And so one thing you might notice about this is that as the volume is increasing, the height is increasing at a constant rate. And so since this is a linear for this portion of the graph, since that's linear, I know that, as the volume increases, the height is increasing at a constant rate. So it's going to be something that looks like a cylinder at the bottom. So it's either this one, this one, this one, but these two don't have like a cylinder at the bottom. So in other words, the radius is constant. So as the volume fills up, the height is going to increase at a constant rate. So we can throw out D and E. And then the second part of the graph is also linear. So we want the top part of the container to also be a cylinder. So we can throw out that one that has the cone. So now the question is the larger part of the cylinder on the bottom or the top? So if I think about this, for this first part of the graph, as the volume increased, the height increased at a faster rate. So that's going to be this skinnier one at the bottom, because as I fill it up with more volume, it's going to go up. The height is going to go up faster. So the correct answer here is A. Number 3, let f be a continuous function on the interval AB. Which of the following is the most accurate interpretation of the average rate of change of f of x with respect to x over the interval AB? So if I think about, I'm just going to draw maybe a picture, A, B, and we have some function. We don't know what the function looks like, but I'm just going to kind of draw some sort of thing. So we'll say this is f of x here. And so I have some continuous function. So the question is, what is this average rate of change? And so we know that the average rate of change is going to be the slope of this secant line. So it's the slope of the secant line. Let's see which of these answers reflects that. So it's not the numerical mean of all the rates of change. That doesn't even really make sense because there would be infinitely many, so it's not like you can take a numerical mean anyway. This one says the constant rate of change of a linear function that has the same change in output values as the function f over the interval AB. So that would be this linear function. And so this change in output values, f of b minus f of a, is the same as the function f. So that would be like this height of this triangle would be the same. So the correct answer is B. Let's look at the other answers just to see. the average of the values of f of b and f of a. It's not that. An average rate of change is not the same thing as just taking an average of two y values. And it's not the change in all the values. No, that's not it. Okay. And it's not the numerical mean of all the values of f. No. So the correct answer there is B. So for the next one, we have the following expression represents the derivative of what function? So let's remember our definition of derivative involving this delta x. So that's the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So what I want to do is kind of match up each of these pieces with this. So this is some function so there's some function that's being plugged in here. So when I look at this part, I can kind of see it. So this part has the minus f of x, and it looks like that is here. So that's the f of x part. And then this part of the function here looks like this f of x plus delta x. And so when I see it kind of like that and match those up, I can see my f of x is sitting right there in the blue box. And so f of x is that. And I can see that they're the same because it's 2 times the input to the 7th minus 5 times the input plus 8. So so you can see it in the problem there. Then which of the following statements represents the exact meaning of f prime of 4.2 equals 1.7? So again, just remembering what these different components mean. The 4.2 is the x value. And then this 1.7 is the rate of change or the slope of the tangent line. So you can think of it either way. Slope of the tangent line. You can think of it as an instantaneous rate of change, etc. So if I look at number 1, the slope of the tangent line of the graph of y equal f of x at x equal 4.2 is 1.7. So that is 1. That's true. Number 2, as x increases by 1 from x equal 4.2, f of x increases by 1.7. So that's not entirely true unless the function f happens to be linear or be linear on that portion of the graph. That would be true, but we don't know if f is linear or not. So we actually, we can't say that's true in general. It's only true for certain types of functions. And then the third one, the limiting value of the average rate of change of f over the interval 4.2 to 4.2 plus delta x as delta x approaches 0 is 1.7. And so that is true because that just comes straight from the definition of derivative. So the correct answer is 1 and 3 only. So that's D.